Hello and welcome to week 3 for Ethics in Computing and Technology for the winter session of 2024. Yesterday was your reading day. That was Monday, January 15th. Today, Tuesday, January 16th, is the day you watch these lectures and complete your reading and video check for the base readings. And that is Chapter 7, Evaluating and Controlling Technology. And then Chapter 8, Errors, Failures, and Risks. I don't know how many videos that'll break up into, but I'm guessing 3 to 4. And Chapter 7, Evaluating and Controlling Technology, has 4 sections, all about the need for responsible judgment, the digital divide, Neo-Luddite views. I spelled views wrong there. We'll have to change that right now if I can. And making decisions about technology. Of course, we've spent a lot of time reading about the various types of technology that have risen in the public consciousness and influenced our lives dramatically in the past several decades, and how we might be able to think about the problems that arise. This time we're thinking about technology as a whole. How do we evaluate whether or not a technology is mostly positive or mostly negative? How do we take something that seems to have a force of its own, once unleashed into the world, some kind of overarching idea of technology, so computers or cell phones, they seem to have a life of their own. So how could we go about, as a society and as individuals, go about controlling them? According to the book, and this starts on page 312, we consider questions such as these. Does the openness and democracy of the web increase distribution of useful information or inaccurate, foolish, and biased information? How can we evaluate complex computer models of physical and social phenomena? How does access to digital technology differ among different populations? Is computing technology evil? Seems kind of hyperbolic. Why do some people think it is? How should we control technology to ensure positive uses and consequences? And finally, how soon will robots be more intelligent than people? What happens after that? And she does acknowledge that, of course, you could write a whole book on any single one of these topics, and we can only ever get in a overview little bits and pieces. So we want to keep that in mind. We want to keep in mind that we're just getting the surface of some really, really complex topics. So you may have heard of the phrase, the wisdom of the crowd. There's a whole book about it, Popular Psychology, in which if you get enough samples of people's beliefs, and those people have given their ideas independently of one another, meaning they don't get to see what other people said, they don't get influenced or biased by crowd opinion. In some subset of questions, the crowd does better than a panel of experts. This moves on to page, 314. They talk about Yahoo Answers, where we might think about Quora more frequently these days. Just like the other book, this one was published in 2012, so some of the things are a bit out of date. When you ask somebody generic questions like, are online classes as good as classroom classes? If we can produce enough food to feed everyone in the world, why don't we? You're going to get lots of answers from people who don't know what they're talking about. But again, if you have enough of a volume, it turns out that the average opinion or the median opinion can sometimes be a better predictor of the truth than, as I said, a panel of experts. But truth isn't a popularity contest. Just because a whole bunch of people think that something is true doesn't make it true. And some critics of online technology and ideas like the wisdom of the crowd say that inherently, the way it's programmed, it pushes up popular websites, it pushes up popular answers. Even further, when we go into academic research and scientific research, academics and scientists have cited fewer papers and journals in the past couple of decades than they used to, meaning there's kind of like a circular problem. If you click on something at the top of a search list, it becomes more popular, and then the next time somebody searches it, it's going to get higher up on the list, and all the other bits and pieces of information are going to get pushed down the algorithm, and fewer people are going to see a wider variety of materials. On top of that, sometimes there's information that's not even online, and even though that could have valuable information, far fewer people than used to go to libraries and check out things that aren't scanned or uploaded to the internet. One specific example of possible strengths and weaknesses of the wisdom of the crowd is, of course, Wikipedia. We know that anybody can go on and create entries or edit entries anytime that they want to, and that means when you go and check out a link, you're not necessarily sure that the last person who wrote about or edited the page really knows what they're talking about. Or maybe they're maliciously and purposefully trying to warp people's views of things. And Wikipedia has come back with checks and balances for that. But unlike editorial boards, which do have those panel of experts making sure that what is being published is at least as up to date as possible, you might not get the most accurate information at any given time, even though on the whole, Wikipedia tends to be incredibly reliable. So we're already starting to see this dichotomy, this balance between two things. Sometimes we might need experts, sometimes a whole lot of people coming together from a whole bunch of different perspectives gives us a more well-rounded picture of the knowledge that's out there. The next topic is vulnerable viewers. So, okay, we might think that a reasonable adult human being that is relatively well educated will have some skepticism in their back pocket. Recognize that not everything that they see online on Wikipedia or wherever else, even an editorially published journal or book, could be wrong. And that if it's an important topic that's going to have a material effect on your life, you better check more than one source. But there are also a lot of vulnerable people in the world. Children, the elderly, people with mental disabilities. And what should we do in those cases which someone might not be able to recognize that's what's put in front of them could be detrimental, untrue, or even calculated to manipulate how they think and act. We get a little bit of a trend from base where I do want to point out that you never, I think I've pointed this out before, but it's always worth repeating, you never have to agree with any source that you read. That doesn't mean be so skeptical that you reject everything that's put in front of you, but recognize that everything comes from a perspective. The perspective that I have noticed from the base in the chapters that we have read is she is very pro-business, pro-technology, and anti-government regulations. She's very pro-individual responsibility and tends to minimize collective responsibility. And that can skew her arguments or her analysis toward one angle. And that doesn't mean that everything she says is inaccurate or not worth thinking about. it does mean that we can take a step back and think about other possibilities. The reason I bring this up now, so she says something like, some critics of the web, this is page 316, some critics of the web worry about most about the impact of inaccurate information on vulnerable people. The fears of some tend to edge toward a belief that we or experts or the government should somehow prevent that information from appearing. The many strong arguments for freedom of speech in general are arguments against any centralized or legally mandated way of accomplishing this. What can we do to improve the quality of information? Basic social and legal forces help to a degree. Freedom of speech to provide responses, corrections, alternative viewpoints, and so on. Teachers and parents, competition, fraud and libel laws, and people who care to volunteer to write and correct online information. What else can we do to reduce access to dangerously wrong information by vulnerable people? She talks about narrowing the information stream and taking responsibility. Now, those are two good things to argue for. Recognize that you have a personal set of biases. Everybody does. It's a cognitive way that we function. Our psychologies do confirmation bias. Doesn't matter how smart you are, doesn't matter how well educated you are, the shortcuts that our brains make us all fall prey to confirmation bias. If you've never heard of confirmation bias, we tend to seek out and notice and remember information that confirms what we already believe and reject, ignore, or avoid, even unconsciously, information that doesn't support what we already believe. So when we go online and we can be in our quote-unquote bubbles, whether we are liberal, conservative, neutral, urban, rural, religious, not religious, rich, poor, all these things that contribute to who we are, we can narrow our viewpoints all the way down to everything that we expect already. And in fact, it does seem like a lot of people prefer to narrow the information stream in that way. Once we become aware of it, however, we can recognize the need to widen it a little bit and challenge ourselves and make sure that we're not accepting something just because it's something we already believe. And also, we don't want to abdicate responsibility for whatever mistakes are made in the technology that we are provided with. In Abdicating Responsibility, she gives this cute little poem from page 319. I'll leave it up to you to read it, but it's about a spell checker. But they want to say, use technology, recognize that there are going to be times when it is misapplied, and you have to look at every instance. Like, if somebody's name is similar to another person's name and they get put on the no-fly list or they get rejected for a loan and it's because of some kind of computer error, you need to not say, oh, well, it was just the computer that made the mistake, but instead use the computer as a set of tools to make good judgments. These are all individual sorts of efforts, however. I do think that sometimes she neglects the idea that individual human decisions do not always add up to the greater good. This is an underlying principle of many people's beliefs in how individual human freedom and technology work, as well as some of the basic tenets of modern capitalist economics. Individualist decisions will add up to be what's best for everyone in the long run. But critics have come back with the idea that, one, individuals can't see very far into the long term. Yes, you might have a preference to have a cheaper airline ticket now. So you go buy the Spirit airline ticket for $32. But over time, when everybody does that, Spirit has to cut costs, and then the planes become more and more uncomfortable, and you can carry less stuff to your destination, and we end up at a point where other benefits that we may have chosen have disappeared. So all these individual consumer decisions added up to something that in one metric succeeded, and that's the lower cost of airlines. But in other metrics, safety and comfort perhaps, convenience, the individual decisions have compromised what could have happened to protect those more long-term goals. And that might sound a little bit trivial. We can think about other types of things that individual consumer decisions might not be able to accommodate for, like the protection of human rights, so justice, fairness, empathy, equality, protecting the environment, education for its own sake. And we don't want to jump to the absolute other side either. We don't want to say something like, well, okay, if the profit motive can run wild and out of control and trample other human values, well, then maybe we shouldn't have markets at all. And of course, there are people that jump to that extreme. We hear scare tactics about them all the time in the modern media, communism and socialism. But the thing is we want to be careful to not fall prey to a false dichotomy. It doesn't have to be one or the other. We can think about protecting individual rights and decision-making capabilities, and we can also think about the greater good and the long term and how we might want to balance individual human freedoms with maybe having laws and regulations to protect the greater good in the long term. This isn't even a tech issue necessarily. We already have laws that sort of mitigate the free speech thing. I think I mentioned it in a previous video. Like, you can't shout fire in a crowded theater because you are creating harm, immediate physical harm to the people around you. So you cannot have freedom of speech that incites harm. That is an exception, because your individual right to say whatever you want stops when you start to hurt other people with that speech. The problem is sometimes, for many humans, many very smart experts, recognizing that it's hard to find the middle ground. It's hard to say, well, okay, we shouldn't regulate any speech. Everything should be free, all the way up to what point? What counts as harm? We might know that yelling fire in a crowded theater is likely to cause a stampede, but what about hate speech online or medical misinformation? The nature of vaccines is a well-studied sort of case or model for this, and if you might be interested in that, looking forward to your final informal essay. And I have gone a little bit far afield here, so let's bring it back and go to 7.12, computer models. So that is on page 321. And I think this is one of the cooler parts of this whole book, because computer models are, I don't want to say a new tool, but they give us a new view into the world that we couldn't necessarily see otherwise. So if we're thinking about the complex systems that happen all around us, like the weather or the stock market or long-term time periods from the dinosaurs up to now or even further back, our brains just aren't equipped to understand those kinds of huge complex models. But with the advent of computer power, we have developed tools and windows into things that our human brains focused in on the moment could not have access prior to. Yet, we want to be careful. All models are not created equally. So first off, I guess we can think about what is a model. And that's just some simplified version of a complex system that tries to capture the most important variables so we can understand how the system works and make predictions about how it's going to work in the future. And we get some really simple ones on page 321. Where does she have it? Well, like chemistry class. You walk in and there's a model of a molecule with balls and sticks that create a representation of water or carbon dioxide or some other simple molecule, which is of course a model that is much, much bigger than the actual molecules themselves. And the opposite you can think of that she brings up here is a model airplane. If you've ever made a little model from a kit, of course it's much smaller and it doesn't fly. But we know what it's supposed to be because there are data points on the model that are similar enough to the real thing where we can make a map one-to-one from the real thing to the model. And we can model all sorts of stuff mathematically. 7.1, the figure, we get population growth, cost of a proposed government program, when will we run out of a critical natural resource, threat of global warming. But how do we know how to evaluate a model? How do we know if the people who developed the model chose the right simplification points? Do they know enough about the background science to make sure that their model is a reasonable copy or facsimile of the phenomena you're actually trying to understand? And throughout all the examples that BASE uses, we have 3 questions to think about how to judge a mathematical model. This is page 322. How well do the modelers understand the underlying science or theory, whether it's physics, chemistry, economics, whatever, of the system that they're studying? How well understood are the relevant properties of the materials involved? And how accurate and complete are the data? That's number 1. Number 2, models necessarily involve assumptions and simplifications of reality. What are the assumptions and simplifications in the model? And 3, how close do the results or predictions of the model actually correspond to the results from physical experiments or real experiences? Then we get one big question, the difficulty, if not impossibility, of numerically quantifying variables that represent human values and choices. Okay. So I won't talk about every last detail, but we will see the big examples. She talks about car crashes and climate changes. So first we talk about car crashes to get a sort of sense of how modelers simplify things. We know we've probably all seen video of the crash test dummies, the real thing, where actual cars are crashed to see how they hold up for safety purposes. Of course, that's super expensive and time consuming. And if you really want to vary bits and pieces of your design, you can't do hundreds of iterations of building a car and crashing it. It's just not practical. So once you do have some actual physical data, you can translate that into a computer model as best you can, run the simulations, and test it up against either prior actual demonstrations or crashes in physical reality or a new one with your new specifications. So here I'm just going to read this out because I'm not an expert in this either. 323, the bottom. Car crash analysis programs use a technique called a finite element method. They superimpose a grid on the frame of a car dividing the car into a finite number of small pieces or elements. The grid is entered into the program along with data describing the specifications of the materials making up each element, e.g. density, strength, and elasticity. Suppose we're studying the effects on the structure of the car from a head-on collision. Engineers initialize data to represent a crash into the wall at a specified speed. The program computes the force, acceleration, and displacement at each grid point and the stress and the strain within each element. It repeats these calculations to show what happens as time passes in small increments. So just imagine a very small celled grid being put up onto a screen on top of a car getting ready to hit a wall. As time passes in each tiny little cell, the program takes the temperature or the sample of each cell in the grid, and then at the end it can add it all up and we can see how the model of the car held up. So we ask our 3 questions. How well is the physics of car crashes understood? How accurate and complete are the data? And we get to know that the engineers and scientists behind it know how the material works in regular conditions very, very well. When it comes to high-speed changes and high forces, we know a little bit less. That's one of the reasons we do the models. What simplifications do the programs make? The grid pattern is the most obvious in real life. You can't discretely break up a car into points. It's just the entire car. Time is also analog and continuous, not digital. And how do the results compare to an actual crash test on real cars? Turns out pretty good. As we've refined these models more and more and the grid size has gotten smaller and smaller, like a limit in calculus, the models have gotten better. And one of the reasons we learn about this is because climate change modelers use a similar grid system over the whole world. And that is one of the strengths and weaknesses of climate change modeling. Because when they first started in the late 80s and early 90s, there wasn't enough computing power or background information to make those grids much smaller than 500 kilometers. And now, decades later, we're down to 100 to 300 kilometers, which is a lot better of a resolution. And we get some of the strengths and the weaknesses of climate change models and the failures and the successes that have happened over the years. I'll leave that to you. There'll probably be a question about it in the reading, and we can move on to the digital divide. This is a pretty short section because the digital divide has been closing. When I was your age and in college, there was a big gap between the rich and the poor, white people and people of color, and the West versus the rest of the world in who had access to computers and computing technology. Very, very big divide. And that's closed over time. Men and women have equalized. Poor and rich in the United States have mostly gotten access to computers and even broadband. Again, this was written in 2012, so you always want to make sure that we check that we are up to date. I got some data here. Still not perfect. I got from a place called AEA Web. It's an economic forum. In 2021, 56% of poor families at the poverty line in the United States did have computers in their homes, including mobile phones. For global stuff, this one says 2 billion, and now the data are 5 billion people around the world have access to the internet. So of course, maybe there's not the haves and the have-nots when it comes to technology, Base proposes. Instead, it's the haves and the have-laters. There's a bit of a problem with that, but one thing I want to talk about quickly here is the idea that technology can count as a positive right. We talked about positive and negative rights. I mentioned a bit about how we have in American federal law that everyone has to have access to the telephone network, because it wouldn't be just if poor people could not access the emergency services network. Above and beyond that, you need a telephone, or you needed a telephone before the advent of the internet, to get a job, to keep a job in many, many instances. You'd need to be available for your work to call you and say, hey, you're hired, or this is your schedule. Nowadays, it is drastically harder to do almost anything in life, but especially to get a job if you do not have access to the internet. So some people argue that once something is in place that you have to have in order to thrive, it becomes a positive right of someone in that society. And some people think of that as broadband, or having some kind of computer in the home. And I see now that we're approaching the half an hour mark, so I'm going to close part 1, and I will see you in part 2.